Alright, this is Honors Geo, Chapter 8, Section 4. Properties of rhombuses, rectangles, and squares. Okay, so we talked about a parallelogram, right? We said a parallelogram is a quadrilateral in which opposite sides are parallel. There's figures that sort of stems from that family tree, and one of the figures that stems from that family tree is a rhombus. So this is a parallelogram. Here we have a rhombus. And a rhombus is also a parallelogram. But it has one caveat. It's a parallelogram where all four sides are congruent. All four sides are congruent. So I'm going to draw this again. It's too small. All four sides. You can think of it sort of as a diamond shape. A lot of people think of rhombuses as diamonds. So I'll draw that. All right. Parallelogram. All four sides are congruent. Okay. And then we have a rectangle. And a rectangle is also a parallelogram. And opposite sides are parallel. However, what separates this from a regular old parallelogram is that it's a parallelogram with 490-degree angles. So this is a rhombus. This is a rectangle. And then one day, rectangle saw rhombus and thought she was looking, kind of cute. And rectangle shot his shot. And they got married, y'all. And after they done got married, they done had a baby. And their baby turned out to be square. A square is also a parallelogram that combines the characteristics of rhombus and square, in that we have 490-degree angles and we have all four sides congruent. Puts everything together. Alright, and this is the parallelogram family tree. All stems from the parallelogram. Opposite sides are parallel. Then we have rhombus. Opposite sides are parallel and opposite sides are congruent. Then we have square. Opposite sides are parallel. All four sides are congruent for the rhombus. Opposite sides are parallel. All four sides are congruent for the rhombus. For a rectangle, opposite sides are parallel. Opposite sides are congruent. And you have 490-degree angles. Then you have a square. Parallelogram where all four sides are congruent. All four angles are 90 degrees. Okay. So here's the definition of the rhombus here. I'm not going to write it down. A rhombus is a parallelogram with four congruent sides. That's it. Then we have a rectangle. A parallelogram with four right angles. and then you have a square. A parallelogram with 4 congruent sides and 4 right angles. Okay. 4 congruent sides and 4 right angles. That is a square. Okay. Which leads me to corollaries. Very heavy on definition, not really a lot of examples, mathematical examples. Rhombus corollary. A quadrilateral is a rhombus if and only if it has 4 congruent sides. So it's just a definition of a rhombus. And the rhombus corollary, rectangle corollary, square corollary is all this. It's basically the definitions. Right? A quad is a rhombus if and only if. I'll draw the 3 equations for if and only if, 3 lines. If and only if it has 4 congruent sides. Alright, rhombus corollary. Then you have the rectangle corollary. And again, it's just a definition. And same thing, a quadrilateral is a rectangle if and only if it has 4 right angles. Then you have the square corollary. Quadrilateral is a square if and only if it is both a rectangle and a rhombus. Pretty straightforward. Quadrilateral is a square if and only if it is both a rectangle and a rhombus. Okay, and then there's other. This is sort of how they write it. They use sort of a Venn diagram. They have parallelograms on the outside, and they have the rhombus's characteristics over here, and then they have the rectangle's characteristics over here, and they put them together, and there's the square. Look at the baby, so cute. Okay. So there's a couple questions here, and it's funny. I looked at them; they're all the same questions essentially. For any rectangle E, F, G, H, is it always sometimes true that FG equals GH? So it says it's a rectangle. So I know a rectangle is a quadrilateral. That's a parallelogram such that it's has 4 right angles. EFGH. They want to know if FG can equal GH. Can FG equal GH? Is that possible? Always or sometimes? Well, in this case, that's not going to happen. But there is a case where it does happen, and it only happens when EFGH is a square. remember, a square is a rectangle. It's just a special type of rectangle where all the sides are the same. So if it's a square, then yeah, absolutely. So this would be a no. This would be a yes. So the answer is sometimes. Alright, sometimes. And it's only when it's a square that EF would equal GH. Remember, a square is a rectangle. A square is also a rhombus. It's both. Sketch a quadrilateral with 4 congruent sides and 4 congruent angles. Sketch a quadrilateral. Well, okay, I'm gonna go back. This is a quadrilateral with 4 congruent sides and 4 right angles, so it's a square. I mean, yeah, it's a square. All right, theorems. Theorem 811 says that if we have a rhombus, if it's a rhombus, meaning that all 4 sides are congruent and opposite sides are parallel, if we were to draw the diagonals, those diagonals would be perpendicular to each other. If we were to draw the diagonals, those diagonals would be perpendicular to each other. Alright, so theorem 811. If a parallelogram is a rhombus, a parallelogram is a rhombus if and only if the diagonals are perpendicular. AC is perpendicular to DB. BD. Okay. Parallelogram is a rhombus if and only if its diagonals are perpendicular. Okay, so diagonals are perpendicular in a rhombus, which also means diagonals are perpendicular in a square, by the way, because a square is a rhombus and a rectangle. So keep that in mind. So whatever applies for a rhombus applies for a square. It's implied. Okay, so theorem 812 says that if a parallelogram is, should I do this bigger? A rhombus. So a parallelogram is a rhombus if and only if diagonals bisect a pair of opposite angles. Okay, so what that means is that I have, let's look at diagonal DB. This diagonal, while it's perpendicular to the other one, also cuts the opposite angles in half. So angle D is cut in half. So we have angle ADB and angle CDB. We have angle ABD and angle CBD. They are cut in half. they're bisected. And then angle AC are also cut in half. So we'd say that AC bisects angle BCD. And we would say angle or segment BD bisects angle ADC. Okay. They are cut in half. And again, whatever happens to a rhombus happens to a square. So the angles in a square are also cut in half by its diagonals. Okay. And then we get theorem 813.